Hello friends. I had a question that came in recently about the notation for taking the second derivative, right? So when we take the first derivative, we're familiar with that notation, right? It looks like this, dy dx. But the thing is, when we take a second derivative, we express it as d squared y over dx squared. And it seems a little bit funny because it would seem like, we've got the two d's up here, so that gives us the d squared. We've got the two x's down here, that gives us the x squared. But then we've got two d's, so why doesn't this have a d squared on it? Right? Why isn't it d squared y over d squared x squared? Well, let's just pause for a minute and realize that what we're not doing here is multiplication. We're not multiplying this. So for example, if we have f of x, right, that's not the same thing as f times x. That's a different thing. And so even when we take, if you write this notation, dy or d dx and y of x, right? So this means that there is a function. Y is a function of x. X is the input, y is the output. We're not multiplying. Same thing, f of x, right? F is the function, so f is the output, you could say, and x is the input. And a function, again, is just input-output machine, and the function tells you the rules for getting the output from the input. And so if we take this whole thing, d dx of y of x, it does not give us dyx over dx, right? So we're not dealing with just straight multiplication here. But conceptually, here's a different way of looking at it too, right? So here are a couple of graphs. We've got y equals x squared, that's what that looks like, and then the derivative of that, so if we take d dx, so the derivative with respect to x of x squared, then we get 2x, right? And that's what's right here, 2x. And so this right graph is the derivative of the left graph. Okay, so what is the derivative? Always keep in mind the concept that the derivative is the function that tells you what the slope is at any point on the original function. So, for example, if I go to the point 2 here, and I want to know, okay, what's the slope at this point? If I'm drawing a tangent line, tricky to draw, then what I can do is go to the derivative function, and then it's 4. So I know that at the position 2, the slope here is 4, right? Slope equals 4. Okay, oh, that's not how you spell slope. This is math, right? Physics, not spelling class. Anyway, so what does it mean, right? So slope is rise over run. And so here's the rise, here's the run. Delta y over delta x. And as delta x approaches 0, so we're talking about some, like infinitesimal, tiny little interval here. And then we go up here, right? And then we have whatever the interval is here. And so this is dy, right? This tiny interval here, and this tiny interval is dx, infinitesimal. And so that's what this notation means. So then, dy is one value. D and y are not two separate values. It's not like two separate variables, right? It's like delta x and delta y. The delta is not a separate variable from the x or the y. So it's one value over another value here. So then if I want to do that over here, this is already dy dx. But if I'm going to find the difference of this, d dx, what I've got now is this is the same dx, but this interval now up here, from here to here, this is now, it's no longer the same dy as the other graph. So I can have the same dx, right? It's still an interval of the input, but now it's a different vertical thing that I'm taking. And so the d here, this interval here, is not the same as the original dy. So I'm not taking dy squared, so to speak, but I am taking a second derivative. And so we note that with a d squared of y and then dx squared. So it's kind of like we've got parentheses here again because dx is one value. It's that infinitesimal horizontal distance from both graphs. So it's that same thing from both graphs. So I hope that clears it up a little bit and helps you understand that the notation does have some meaning behind it. And primarily it's this idea that dx is its own single value. It's not two separate values. And we're not just doing multiplication straight across. It has to do with this kind of function notation. So thanks for watching. Again, feel free to ask questions, post them in the comments below, and like and subscribe.